Yeah, that's his problem because we're having a quiz next time.
Oh, no! Quiz on what?
Can I use this paper?
No, you may not. Use the formula sheet. Start correlating them. Which force of electricity up? What's balancing it?
-40 charge. It's less than electron.
Gravity.
Gravity. Yeah, force of weight. So we know 0 is going to be equal to force of electricity minus force of weight. So force of electricity is equal to force of weight. Okay, so then I look at it and go, all right, so I've got some information about the mass. Force of weight is going to be mg, so this is going to be EQ, right? Electric field I've got is going to be 1.92 times 10 to the 5th. Q I don't know, but when I'm solving for, so it's okay, I don't know that. Now I got to find the mass. And acceleration of gravity is 9.8. So they give us all sorts of information about a drop. We know that density is equal to mass per unit volume. So mass is going to be equal to density times volume. Volume formula for a spherical drop would be what?
4/3 pi r cubed.
4/3 pi r cubed. Unfortunately, the radius of drop is written in a nasty way, and so is the other stuff. So let's do it the hard way. Density. How do I convert density? Which is 0.851 grams per centimeter cubed into useful units. We need kilograms. We need the centimeters and meters, don't we?
Wait, what?
So I have 100 centimeters is 1 meter. I have another 100 centimeters is 1 meter, and I have another 100 centimeters is a meter. And I have 1,000 grams is a kilogram. Right? I'm converting that kilogram, and I'm converting the 3 centimeters. Which, if I'm right, gives me 0.851. Nope, not 0.851. What did it give me? I have 6 zeros on top, 3 zeros on the bottom, so it gives me 3 more zeros. 1, 2, out it gives me this kilograms per meter cubed, right?
Wait, how do you say? Wait, for that's volume?
That's density. Got to convert each one of the centimeters.
Oh my god. 8.025 times. Okay, no, okay, so I just
I'm pretty sure that's wrong.
did that. Oh,
Less an electron, which would be startlingly odd to find.
And therefore, I'm going to blame the people who did the lab.
There you go.
Okay, can I do it this way, even though this is wrong and sick? Because it's the way I'm doing it.
Okay, so
I converted picometers to centimeters.
Oh, don't do that. Picometers.
Took that, plugged in the volume,
Okay.
got my volume,
Uh-huh.
multiplied that
By the density.
by the
That should work.
density,
Yeah.
and then that's my grams so far,
Right.
and then multiply it by 1,000 to get my
Divided by 1,000.
divide by 1,000. So I got
Okay, so I'm going to keep going here. So I got to do this is 4/3 pi. What is my radius in meters?
1.64 times 10 to the negative 12.
1.64 times 10 to the negative 12th cubed. And I got 851 out here.
it's so
I forgot parentheses, so I was trying to make a group do an entire new. That makes it very
4 divided by 3 times pi times 1.64 exponent negative 12 to the 3rd power, boom, times 851. And I get that my mass of this drop is 1.57 times 10 to the negative 32 kilograms.
Put up at 9.8 somewhere. Also, just using 9.8, is that like a gross, like, sin? Because it's just
32.
kind of not very exact.
That's exact enough.
Okay.
I got
Although-
68.
68.
Negative 68. Well, it's like to times the negative 68.
Negative 68. How do you get negative 68? I've got 3 times.
3 times 10 negative 12.
This is, what do we get? Oh, crap. Is it 12? Yeah, it's 12. Is it 164 or 1.64 picometers? 1.6. Oh, it's micro. You guys said pico. That's not pico. That's micro.
Oh, no, the difference between you.
Pico's a 6.
Micro is a 12?
Yeah. No, pico's a 12. Micro's a 6. And micro is a little m, which is what mu is. And pico's a p.
Yeah, I remember that now. Hey,
Because we're gonna get a really bad answer in a moment, so I gotta go back up. That's not pico. A micro.
Hey, it's not my fault you guys didn't read the problem.
Yeah, I probably should read the problem. I know better than to not read the problem when students are involved. Pi times 1.64 exponent negative 6 up to the third times 851. And I get the mass is 1.57 times 10 to the negative 14 kilograms. So now I have the mass. I can plug that into this little beastie. Times 9.8 divided by 1.92 exponent 5, and I get the Q is equal to 8.02 times 10 to the negative 19th coulombs. So that's not what it asks us. We'll get to what it asks us in a second.
Hey, it's like
In terms of E, how many electrons is that? 5. It's 5 electrons. You do the conversion one at a time, right? So you'd say that if I have 8.02 times 10 to the negative 19th coulombs, where 1.6 times 10 to the negative 19th coulombs is 1 electron, I get 5 electrons.
You said this is the good shower, right?
No, this should be the one of the easiest ones. You guys haven't engaged in it yet, which is driving me crazy. That's okay.
This is
I got asked twice by Kinemax equations. I've been asked how to convert meters into kilometers. I've now been asked how to convert P and micrometers. And I mean, we're stumbling on things that 6 months ago wouldn't have stumbled you nearly as badly.
6 months.
Because I'm waving myself with E&M stuff. Because we're talking about E&M, suddenly these are much harder concepts. Density, well, that's a really tough concept. What are we doing here? 47. Here we go. 47.
Okay, we'll clarify.
The good news is 47 is actually hard. The good news is that as time goes on, we're going to be so that's going to be 5.3 exponent 6 sine of 39. 3.67 times 10 to the. That's not right.
I got 5.61 times 10 to 6.
2, 3, 4, 5, 6. What'd you get?
5.6.
Not for sine, there's no way. It says 6. And let's check cosine.
Oh my god. 360.
Oh, you mean how far away?
No, I'm breaking up into comments.
Times 10 to
I
the
see in
6.
radians.
Get out of radians.
And my
Even in radians, you can't be in. There's too high numbers. Like
how
you're
do I check if I'm radians?
on those?
Yeah.
Minutes.
Yeah, I'm in radians.
Okay.
Let's try that again.
All right. So got that. So then what? I'm now going to treat it like a projectile, right? So I'm going to go in the x direction. I got 1/2 at squared plus v naught t. In the y direction, I have 1/2 at squared plus v naught t. First question is, do I hit the top plate?
No.
Okay, I'm pretty sure I don't, but I'm going to try it anyways. So in the y direction, the question is when I get to 0.0197. Now, if I get imaginary, that means I didn't make it, right?
I'm thinking you do hit the top plate.
Well, I'm going to try it. We'll find out in a second. I need the acceleration. To get the acceleration, I'm going to have to go EQ equals F, MA equals EQ. The mass of an electron is 9.11 times 10 to the negative 31st times acceleration, which I don't know, is equal to electric field, which is 1870, times the charge of an electron, which is 1.6 times 10 to the negative 19th. Agreed? So then I'm going to get that the force is 1870 times 1.6 exponent negative 19 divided by 9.11 exponent negative 31st. And I get the acceleration is something silly like 3.28 times 10 to the 14th meters per second squared. Agreed? Negative. Good pulling down, right? So I'm gonna. I note that it's pulling down, so I'm gonna put it in here as a negative. Negative 3.28 times 10 to the 14th. Okay, yeah. So make sure you add 9.8 to this times 10 to the 14th numbers. Do it. Plus 9.8.
What am I going to find? You're talking like you never going to find.
Well, this is 3, 2, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 plus 9.8.
Damn right it is.
So yeah, you do have to add it.
I'm just forgetting about gravity.
I don't want to forget about gravity. You're right. We added it in there, and we get that for an answer. So we move on from there.
How do you know the gravity is 9.8?
Please don't ask questions like that. They make me want to cry. 3.67 times 10 to the 6th times the time here, right? So I'm going to solve for time. If I get a time, I'm excited. If I don't get a time, then I go, okay. Time to give up. Equation, polynomial, second degree. I've got negative 3.28 exponent 14 divided by 2. 3.67 exponent 6. Negative 0.0197. Boom. I get two real numbers. All right. Can only hit it once. So I'm going to go 8.94 times 10 to the 9th. I do hit the top plate. Is that right?
Oh, why?
Say that number out loud.
I got 8.94 times 10 to the negative 9th seconds.
Hey, I got that.
Why are you squinting?
Because something to the negative 9 is smaller than something to the negative 8, right?
Yes.
Oh, you can use the
Jill.
quadratic.
Okay, now I'm going to guess. If you've got a calculator that can do it. So then I plug it in here. So I got x equals no acceleration left or right. Like field pointed straight up and down, so I don't have to worry about that. So I get 0 plus initial velocity is 4.38 times 10 to the 6th times this ridiculously small number. And I get how far that way it goes, right? How far in this direction it goes, how far it's going to strike the plate. So I'm going to menu exit. Exit. No. No, the part that Casio slows it down. So I get 8.94 exponent negative 9 times 4.53 exponent 6. And I get that it hits the top plate 0.040 meters from the left edge. So right about here at 0.04 because it's 0.0620 long. And bam, we got an answer.
Like that.
Make sense?
Yes.